In this problem, we're asked to simplify this expression. Now, this is what we refer to as a complex fraction, and that simply means that it's a fraction where either the numerator or the denominator, or both, as in this case, also contain fractions. Now, there are a couple of standard ways of solving this type of problem, so I'm going to show you both ways. The first method, call that method 1, is essentially to turn this problem into a division of two fractions. So to do that, we need to take both the numerator and the denominator and write them as a single fraction. So our numerator, 1 over a minus 1 over b, I want to write that as a single fraction. And there we would have a common denominator of a times b. So this first fraction, to go from a denominator of a to a denominator of ab, I have to multiply by b, so I have to multiply the numerator by b also. And this fraction, I need to multiply both numerator and denominator by an a. So the numerator as a single fraction becomes the fraction, the quantity b minus a over a times b. Now we'll do the same thing with the denominator. And the denominator here is 1 over a plus 1 over b. Well, using the same approach, we get a common denominator of ab, multiply numerator and denominator of the first fraction by b, multiply numerator and denominator of the second fraction by a, and that becomes the denominator written as a single fraction. So then our original complex fraction can be rewritten. So here's the original complex fraction, and replacing the numerator with it as a single fraction of b minus a over a times b, and the denominator becomes b plus a over a times b. So now we have one fraction divided by the other, and to do division by a fraction, we multiply by the reciprocal. So we flip the denominator and we multiply by that reciprocal. So now you'll see that we have a common factor of both a and b in the numerator and the denominator, so we can cancel those, and multiplying straight across, we get the fraction b minus a over b plus a. So that's one method where you rewrite both numerator and denominator as a single fraction and then treat it as a division problem. Now the second method again uses the idea of the least common denominator, but we look at all of the little denominators. So you notice that in the smaller fractions we have a's and b's in the denominator. So we get a least common denominator of all those fractions, least common denominator of a times b. So instead of looking at them separately, I'm going to look at this as one big fraction, and I'm going to multiply both its numerator and denominator by this least common denominator. So I'm going to take my original fraction and multiply its numerator by a times b, the least common denominator, and its denominator. So that will not change the value of this fraction. Now when I do that, so I'm going to have 1 over a times ab minus 1 over b times ab in the numerator, and similarly in the denominator, I get 1 over a times ab plus 1 over b times ab. Now again, remembering that this AB is really over 1, and we can cancel that common factor of A in the first fraction in the numerator, B in the second, down in the denominator, common factor of A in that first fraction and B in the second, and so we once again end up with B minus A over B plus A. So there are two different methods for simplifying this complex fraction.